Thank you very much for having me on, Jimmy. Now, when presented with the choice of cells between the LG M50LT or the Molicel P42A, I do believe in almost every single case the better choice is the Molicel P42A. And the main reason for that is voltage sag. Now, voltage is basically the electrical pressure that makes electrons move. At rest, a full lithium-ion battery cell measures at 4.2 volts. And when you draw current from a cell, similarly to opening a faucet, the pressure drops. And this is seen in the form of voltage sag. And how much that voltage actually sags depends on some of the characteristics of that specific cell. Now, a higher capacity low current cell, like the MG M50LT, which is commonly known as an energy cell or a storage cell, will have more voltage sag because in order to have more capacity in the cell, it will also have a higher internal resistance. The cell's internal resistance is literally how much it resists the flow of electricity through the cell. And higher capacity cells usually have a higher internal resistance, leading to more voltage sag. Cells like the Molicel P42A, which are commonly called power cells, generally have a lower capacity but a much lower internal resistance. And so for the equivalent size, shape, and configuration of battery, a cell like the Molicel P42A will have much lower voltage sag. And that simple fact resonates throughout the entire system of a PEV. One example is when the motor controller, or the ESC, is drawing power to drive the motor, a drop in voltage from the power source, the battery, will actually require more current in order to make up the equivalent wattage sent to the motor. And this is actually something you can feel. If you've ridden either a one-wheel or an electric unicycle and you've felt the perceived torque from the motor start to sag or drop out a bit, that is a result of voltage sag from the battery echoing all the way through the system. If the battery sags too much and the motor becomes starved of power, that can lead to faceplants, nosedives, cutouts of all sorts. It really depends on the actual battery level that's remaining, but that sag does cascade and usually results in something that you perceive as a rider. Another effect of voltage sag is actually the end result of the mileage that you could get on any given charge. As current is drawn from the battery, the voltage continues to drop as you empty the cells out, and motor controllers are programmed with a low voltage cutoff in order to not overdrain the battery and damage it. Cells with less voltage sag actually end up delivering a much more constant drop in voltage throughout the entire charge range, which in many cases ends up delivering more energy and more range despite the lower actual capacity rating of the cell. Which sounds counterintuitive, but the effects of voltage sag in an application like an electric unicycle do end up translating into those kinds of effects. In almost every single case, choosing a cell with a lower capacity but a much higher discharge rating leads to more range, less sag, and a more consistent experience from the top to the bottom of your charge. So thank you, Jimmy, again for having me on, and I hope I was at least a little bit helpful.